Hey there, people. Today we are talking about section 4.3, derivatives of inverse trig functions. So we're going to talk about regular inverse functions. We're also going to go through and do inverse trig functions. Again, if you need something that I'm going too fast, and I do know I talk quickly, pause the video, write it down, and then press play again, and you can catch right back up with us. So we are talking again about inverse functions. We are interpreting graphs between a regular function and its inverse and their derivatives. And then again, we're going to the inverse trig functions and all that really, really fun stuff. Woo. Okay, so the first thing that you're going to talk about is the derivative of any inverse function. So on any inverse function, we go through and we need to talk about how the original function needs to be differentiable on any point on interval I. So they're giving you this interval. The derivative is never zero on that interval, so it never crosses the axis. And f has an inverse. F prime is differentiable at every point on that interval as well. So they're saying if f inverse of A equals B, the inverse slope relationship relates to the derivatives by this equation. So we have a lot of stuff going on here. Let's get a color. So they did say that we have inverse of A gives us B, value B. So in the original, we got f of B equals A. Okay, so f of B equals A, and we know that because when we first learned about our inverse and our original, inverses and original, we always switch the x and y first and then solve for y. So that's just what I did. It started with the inverse and it gave us inverse of A equals B. So f of B equals A. That's how those functions are related. Then when we're dealing with the derivatives, if we know the derivative of f, if we know the derivative of this, we can use that to find the derivative of that, and it's going to be 1 over this derivative. I'm going to show you how it works on the next page. So, excuse me. Functions f and g are inverse functions, so I gave you 2 different letters, so it might be a little bit easier. F of 2 equals 5. What do we know about function g? Well, function g is just going to have, since it's an inverse, your x and y are going to be flip-flopped. So f of 5 equals 2, and I can plot that 1, 2, 3, 4, 5, and 2. They are going to be the same across that line, y equals x. Okay, I'm also going to plot some other ones because I'm going to try to draw this curve in here. So this is 0, 3, so I'm going to have 3, 0. This is -1, 3, so I have 3, -1. I have this point 3, 1, 2, 3, 4, 5, 6, 7, 3, 7. So I'm going to plot 7, 3. And then this point right here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So 6, 7, I'm now going to have 7, 6, 3, 4, 5, 6. And it roughly looks like this. Kind of circle. It's pretty close. It does a little bit more of a curve at the end there, but it's pretty close. Okay. So it says on the next part, f prime of 2 equals 3. So that means the slope when x is 2 is about 3. So right here, and I tried to get it as close as I could for this example. So I'm just doing up 3 over 1 for slope, 1, 2, 3 over 1. So here is the slope at that point. I did pretty good. Okay, so as we see our inverse functions relate over this line, y equals x, this guy here is going to go up 1 and over 3. So the slope, again, I'm going to erase these little lines here, the up 1 over 3. But what's going to happen here is the slope ends up to be 1 over 3. In order to reflect, they are going to be reciprocals. Okay, not negative reciprocals, they're not perpendicular, just the reciprocals of each other. Okay, so that's how it works. If I know the derivative of this one, I can find the derivative at g prime of 5, and that's again 1/3. Okay, next we have derivative of arc sine and derivative of arc cosine. So please go through and write this down. I'm going to move on to the next page. Notice that sine and cosine, the only difference between the arc sine and arc cosine, or inverse sine, inverse cosine, is that the cosine is a -1. The rest of it is all the same. So we are first doing this equation. So let's talk about finding this equation. If you're doing the derivative of arc sine, okay, it's going to be 1 over square root of 1 minus my u squared, and u is going to be this value in here, the inside part of the function. So u, oops, squared, there we go. So 1 minus u squared, all underneath that, times the derivative of u. So this is like the chain rule. So derivative of u is just 16x. So when we put this all together, we get 16x over square root of 1 minus 64x to the 4th. Come back, come back. Da, 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 da. There we go. Okay, so we're going to move on to the next one. Again, derivative of arctangent and cotangent. I think this one out of the 3 of them that we're doing is the easiest one. And I only say 3 because, cotangent and tangent, the only difference is one's a negative and one's a positive. So all the co-functions, cosine, cotangent, cosecant, are negatives. The other ones are positive. So again, write it down. I'm moving on to the next page. So we have arc secant and arc cosecant. This one is not my favorite one out of the 3 of them. So it just has a little bit more to do with this. Again, you have the absolute value of u in the denominator, but it's just plug and chug. Basically, memorize these 6 equations, and then it's just a plug and chug, and you guys are great at that. Okay, so we are doing secant. So secant function. So in order to do secant, I want to think that this guy right here is going to be my u. So in my function, I'm doing a u. It's not a co-function, so it is just going to be 1 over. So I have 1 over absolute value of u, square root of u squared, minus 1. That's all in the denominator, all sorts of fun stuff. Then we multiply by the derivative of u, okay, which is that. Finally, we are going to simplify. So in the top, I have 3. This is not going to change. Down here, let's see, we got n squared minus 24, x plus 16 minus 1. So get all this. Yep. There we go. Okay, and last problem. Yes. We are doing the derivative of this guy. And when we do that, this is going to be your u value. So again, I start with 1 over, and it's 1 plus, oh, it's negative because it's cotangent. I almost forgot the negative. So we put the negative in there. And then we have our u squared times the derivative of u, and simplify. So I get negative 2x all over 1 plus x to the 4th. And we are done. Thanks for playing.